This conference will now be recorded.
Good morning, everyone. Let us start with the session. My name is Srinivas. So I'm the founder of the institute, and I also manage the front-end domain-specific training at the institute. As you are aware, VLSI has two domains, majorly front-end domain and one minute. I'll switch to. As you are aware, VLSI has majorly two domains. One is the front-end domain, one is the back-end domain. As we go forward, we will discuss what are the subdomains in each of them. Like in front-end, what all activities are done. In back-end, what all activities are done. And we'll also discuss about how to choose a right course. Today's session is more specifically focused on the front-end domain. So this is the agenda. We'll be starting off with understanding what all courses we'll be starting today, and a basic overview of the institute, just understanding of electronic systems, just to get what is a VLSI, what is embedded system, what are the opportunities. Then we'll also understand about VLSI design flow, what is front-end domain, what is back-end domain. We'll talk about different job roles in VLSI domain, and what is the skill set required. How do we choose a right domain, and the institute facilities, how to prepare for the job. So this is the overview of today's agenda. Uh, this session is common for everyone. There could be people attending front-end domain functional verification training, some of you could be attending DFT training, maybe few of you might be attending FPGA training also. Okay, we don't do a dedicated demo for each and everything. We have this common 2-3 hours demo, and then specific to each domain, like specific to DFT will have another demo session, specific to FPGA will have another demo session. Okay, because this content is same for everyone, there's no need to repeat this multiple times. So hence we are having this common demo session. So first let's start just about brief about myself. I'm the founder of institute. I did dual degree from IIT. 11 plus years of professional training experience. I've been teaching since 2012, and around 14 plus years of industry working experience. I do multiple corporate trainings. I mean, as an institute, we keep ourselves differentiated from other institute, where we offer some advanced courses which other institutes don't offer. Because of that, we do a lot of trainings to the companies. Even in March, I have every day almost I have a training with companies. So let's now start with what all courses are starting to. One we are starting is RPL design and functional verification training. The same course what you see here can be called as, even when we say front-end training for freshers, it's the same course. Even when we say design verification course, it's the same course. Functional verification training for freshers, it's the same course. ASIC verification, it's the same course. All these courses are the same ones. Then functional verification training for experienced engineers is a separate course. And this course is for freshers. The first one is for freshers. Again, I'm repeating, these four and this everything is exactly same. Because sometimes some students may say I want front-end domain training. Some students may say functional verification. All of them are same in our context. Then sometimes you may say, for experienced people, why do they need training? Can someone tell me, why does experienced person need a training? He's already working. Why do you think he requires training?
Updates will come in the society, so we need to update everything.
Yeah. So many times what happens is, someone who is working in the industry doesn't get to work on everything. Let's say one project happens for 8 months. So he will be only involved in one part of the project. he won't be doing entire flow starting from the specification till project completion. He won't be doing. In those cases, they come to the institutes for filling that gap. Then there will be some new protocols and new technologies coming to upgrade, upskill themselves for that. They'll be coming. We have actually a lot of people joining for our experience courses. Almost out of every two people, one person who joins our course is an experienced person. Then we have course on Verilog for design and verification, system Verilog for functional verification. These courses are actually meant for people who are currently pursuing their BTech. I mean, who are in their third year of BTech or fourth year of BTech. They won't be able to spend 6 to 8 months time. They won't have so much time, right? Because they have their own coursework. In those cases, they go for these courses. Then we have course on FPGA design and verification. We'll also talk about what is FPGA shortly. Then we'll talk about we have course on RTL design and integration. You see the difference. One is verification, one is integration. These are the two different courses. Then we also have course starting for DFT, which is design for testability. Okay. So this is the list of courses starting today. The reason why we are doing as one common demo is, again, there are 7-8 courses. If I have to offer a demo every day, we have to have a demo. Okay. The front-end course demo, this demo will go from 9:30 to 12:30. And the DFT demo, our admin will inform you. Our admin will inform you the schedule for the DFT specific demo session. Those who have enrolled or have registered for DFT specific session, our admin will inform you the schedule over the WhatsApp. So before we start, do you have any questions? So let us wait a second. So first, let us start off with understanding of electronic systems. As you are aware, any electronics consists of multiple aspects. Okay, it's not just the hardware. So in this part of the session, we want to understand what all things makes up an electronic system, so that you would understand what is the difference between a hardware, embedded system, and software. So to understand this, to understand an electronic system, let's start with understanding what goes into a mobile phone. Now, if I take a mobile phone, this is how it would look like. If you open the mobile phone, you will see various components. Okay, it could be the main SoC chip and the various units like camera module, display module, USB port, various things. That is what makes up the mobile phone. But if you see, the mobile phone is not just about the hardware. What you see, if you just take this without, if you don't load any operating system, or if you don't load any drivers, it won't work. Let me again repeat. If you just take the plain hardware manufactured and if you start using it, it won't work. Can you tell me, for it to work, what all things we need to do? We need to add some code. There will be some memory in this, in which we have to load some image, boot image. Then we have to load some drivers and then we have to load some operating system. Then only you can start using the mobile phone. Let me again repeat, mobile phone just as a hardware, it doesn't work. Just the hardware alone doesn't have any value. On hardware, we have to keep few more layers called as embedded systems, then operating system. Only then you can start using the mobile phone. The same thing applies for every other hardware. Even if I take my laptop, even if you take this one, let's say remote, what I'm having in my hand. For anything, you need some kind of drivers or some kind of operating system to make it work. So now let us understand what are those things that makes up the entire electronic system. So what all things make up a mobile phone? First thing you can think of is what? Hardware. What is hardware? Chips, processor, screen, some USB port, camera, sensors, various things makes up the hardware. Then there are things which we don't see. What are those? For example, operating system like Android, iOS. Then you have firmware, the drivers, what we call as drivers. Then we have applications. So if you divide mobile phone into multiple layers, it can be divided into 4 layers. First you have is the hardware. So hardware has processors, camera, and sensors, various things that makes up the hardware. Can someone tell me who makes the hardware, who develops the hardware? The VLSI. Please just read through this once. I'll be back in a minute. So if you have gone through it, basically you will understand that the hardware engineer, hardware is developed by the VLSI engineer. His only responsibility is to develop the hardware. He doesn't do anything else other than that. He will not develop any drivers. He will not work on any operating system or applications. Whereas the second layer is what? Firmware. Who develops the firm? What is firmware? different drivers like USB driver, those kind of things. Who develops the firmware? Embedded system engineer. And third is what? Operating system, like Android OS, iOS, different things. Who develops OS? It's the software engineer. The fourth is what? Applications. Applications in mobile like GPay, Maps, various things, right? Like WhatsApp. Who develops that? Software engineer and app developers. Basically, for any electronic system to work, all these four layers are essential. Let's say without hardware, can I have mobile phone? Without mobile phone hardware, it is not possible, right? Same way, without drivers, mobile phone will not work. Only just a piece of hardware will be there, but it won't work. So everyone has their own importance. So it is not like that only hardware is important or only embedded is important. Everyone has their own importance. Okay. Um, so let's take a simple analogy to understand this. To understand what is the significance of all these layers and how do they interact with each other. Let's take a simple example. Let's consider bus with passengers. Example of bus with passengers. Bus is like the hardware. The driver, the bus has the driver, right? He is like a firmware. That's why the name driver came actually. That is the reason why the name driver came. Because what does the driver do? Does he manufacture the bus? No, right? Same way, embedded system engineer does not manufacture the hardware. What he does, he uses the hardware to make it work as he wants. Like the driver controls the bus, right? Like turning or increasing the speed, slowing down or anything, he controls it. Then who is the third entity? Conductor. What is a conductor? He is like the operating system. He is the connecting point between passengers and the driver. Because let's say you are sitting in the back of the bus. Will you tell to the driver to stop bus? No, right? Whom we will tell? Conductor. What conductor will do? He carries that information to the driver. Then what driver will do? He understands the instruction. Let's say sometimes you want to slow down, sometimes you want him to go fast, you want him to take left turn. That you will tell to the conductor, he will tell to the driver, and he will accordingly act. So passengers are what? Applications. So how it works? Anything you want to do, let's say passenger wants bus to stop. So will he go and apply the brake himself? No, right? What he does? Inform the conductor. What conductor will do? Conductor informs driver. What driver will do? He has a controls. Then he stops. It's like a simple analogy. Similar thing happens in electronic systems also. Similar thing happens in the electronic systems also. Where when you, simple example, let's say you have a mobile. I think that example will be there. You have a mobile. If I don't use it for half a minute or 1 minute, what happens to display? It gets off, right? How does it happen? Okay. Or for example, let's say it gets off in 30 seconds. Now I want to change the time to 60 seconds. Right now my mobile behavior is like this. If I don't do anything for 30 seconds, it will go off. I want to change the time to 60 seconds. I want to change the time to 60 seconds. So how it can be done? You go to the applications, settings or applications. There you change it. That information goes to the operating system. Like it's like passenger is telling that change the time to 60. Whom you have told? Conductor. Conductor goes and tells to the driver. Same way, operating system tells to the drivers. There will be some display drivers will be there. Display controller drivers will be there. Okay, or power management drivers will be there. Power management drivers will be told that change this number to 60. Then they will have some register programming. Inside the design, there will be registers. By programming those registers, we change the number to 60. Now, coming back to our example, when USB is connected to the laptop, USB device gets detected. My laptop will detect that USB drive is connected. Then we start doing the transfers to USB device. USB driver, when I say USB driver, that is nothing but the firmware. It is a set of assembly instructions which control the USB related hardware behavior. Embedded system engineer develops these drivers, generally done using embedded C language. Does bus driver manufacture the bus? No, right? Same way, embedded system engineer is only responsible for development of the drivers. So as I said, like the bus driver doesn't manufacture the bus, he only controls the bus. Same way, embedded system engineer is only responsible for developing the drivers on top of the drivers on top which work on the hardware. So what is use case I told you, right? Let's please read this once. I hope you have gone through it. So basically, this is to tell you that there is a specific interaction happens between each layer. Means the operating system doesn't directly interface with the hardware. Even software doesn't directly interface with the hardware. So there is a specific layers through which they interface. Sometimes you can have a bus where there is no conductor. That means what? Driver himself is doing the both the roles of driving and conductor kind of. Something like that also is possible where you can go to some applications where real-time operating system, RTOS, those kind of things they will develop. So let's not get into deep of those things. Just understand that there is this concept. Okay. Why is it important for VLS engineer? I mean, see, the first thing is, as a VLS engineer, what is the responsibility? Manufacturing of the hardware. Then why VLS engineers should know other things? Okay. So going back to that bus example, the person who is manufacturing the bus should know how to provide convenience to the driver, should know how to provide convenience to the conductor, should know how to provide convenience to the passengers, right? Let's say he keeps the accelerator in one place, brake in another place. Will it work? No, right? All the three controls, whatever controls for driver should be in one place only. Same way, someone who is manufacturing the hardware should develop in such a way that it is easy for embedded system engineer to work with it. It is easy for the applications to run on it. It is easy for operating system to run on it. Simple example is what? You have manufactured a bus with only 2 seats. Though it can carry 40, your expectation is 40, but you have only manufactured 2 seats. It has got driver, conductor, everything. Is it of any use? So it's like what? You have created a hardware with less resources. So all these things, so the person who is manufacturing the bus has to understand how much resources I have to give. Can he give 200 seats? You can't give too much excess also. Too less also you can't give. You need to have some specific thing. So as a VLS engineer, the person, as a VLS engineer, the person who develops this hardware should be aware of how that hardware will be used, what is the expectation and all those things. As a VLS engineer, we need to understand how the hardware works. This in-depth understanding is required because you need to develop the hardware. You should have a very in-depth understanding of hardware behavior. You should also know how firmware interfaces with the hardware. I mean, how your next layer. See, what are the layers that we discussed? Hardware, below that firmware, operating systems,
OS.
then you have apps. So the person who is working at this level, person who develops the hardware, should be having very in-depth understanding of this and should know how firmware and hardware interfaces with each other. Right? If I talk about firmware engineer, what he should be knowing? He should know about hardware. He should also know about operating system. I mean, how operating system is going to work with firmware. Okay, something like that. Now, as a VLS engineer, what is your role? To develop hardware. So, what is the understanding you need to have? A in-depth understanding of hardware, a basic overview of how firmware works with hardware. You understood? So you are not going to develop the firmware. As a VLS engineer, you don't develop the firmware. Okay. But you create the hardware in such a way that it is easy for this firmware to control the hardware. Finally, going back to that bus example, when you manufacture a bus, you want it to be easy for the person to use, right? Let's say I have a car. If I cannot use it, if it is very difficult to drive the car, the way the car is manufactured, then there is no use, right? So all those things he has to keep in mind. Okay. I won't go deep into it. I mean, this firmware understanding is required when we do SOC verification. There will be a type of verification called as system on chip verification. When we do that verification, you need this level of understanding. You need to know how firmware controls. A basic understanding of how firmware works with hardware. We don't need to worry about operating system. You don't need to worry about other layers, upper layers. So you understood what
this firmware is developed by RTL code or
which one?
firmware interface?
Firmware is developed using embedded C language. Embedded C language will be finally converted into assembly instructions through compiler. That assembly instructions will be converted to hexadecimal code. That hexadecimal code is nothing but an image, some series of codes that is loaded into the memory. Then my processor gets those instructions and executes them. At the end, anything you develop finally gets converted to assembly level because processor only understands assembly instructions. Even when I gave you an example of changing the mobile display time from 30 seconds to 60 seconds, there also assembly instructions are involved because finally all that work has to be done by processor. Inside my mobile, there is a processor. Processor doesn't understand English, doesn't understand Verilog also. Only language it understands is what? Assembly. It has its own instructions like add, sub, mul, branch, different instructions are there. Whatever thing we did from the application level, like let's say I took my mobile, I went to the application, I changed number 30 to 60. I changed number 30 to 60. Finally, it will, that whatever you did gets converted into some assembly instruction, which gets executed by the processor. When it executes, it essentially changes number 30 to 60. That is where your mobile phone now will start going to idle mode after 60 seconds instead of 30 seconds. Any questions so far? So now tell me, how many layers are there in electronic system? 4 layers. What is the most basic layer? Hardware. Above hardware, what is there? Firmware. Above firmware, operating system. Above operating system, applications. So they have their own way of interacting. Simple example is like what you want to tell to the driver, that conductor, that stop the bus. You will tell stop the bus. Will conductor tell the same thing? No, he will have his own way. He will whistle in a different tone. To go fast, he will whistle in a different tone. Right? So they have their own way. Same way between each layer, there's a way of communication called as APIs, application specific interface calls. Okay. So I think we are deviating from VLSI. I'm just giving you a top level overview. Now the question comes, why are we discussing this? Many times, someone who passed out of BTech don't have that clear picture of what is VLSI, what is embedded system. Even when I passed out of my college, I was not sure what exactly is VLSI, what is embedded systems. Okay, so it is important or good for you to know what is VLSI engineer does, what does embedded system engineer does, what does a software engineer does, and how do they interface with each other. Means how do they talk to each other. So now that we have understood different layers, let us now focus only on the VLSI part, that is the hardware part. Who is the person who develops the hardware? It's the VLSI engineer. Who is the person who develops drivers? Embedded system.
Embedded design.
So now let us focus on the VLSI part, hardware part. So let's understand different styles in which hardware can be developed. Different styles in which hardware can be developed. VLSI stands for very large scale integration. What are we integrating? When you say integration, what are we integrating? Tell me, what are we integrating? Like
Components
let's say I'm
like
constructing a house.
capacitor.
What are we integrating to construct the house? Bricks. Majorly bricks and then other things. But major part of it is bricks. Like that, for a chip, what is that we are integrating? It is the transistors. You integrate transistors, put together all the transistors, is what you get is a chip. Since we are integrating billions of transistors, it is called as very large scale. Why the term very large scale? because we are integrating billions of transistors. VLSI, this process of hardware development can be done in two styles major. There are two major styles of developing VLSI chips. One is ASIC, one is FPGA. ASIC stands for application specific integrated circuits, where hardware is developed for specific application only. In ASIC, hardware is developed for specific application only. Example, mobile phone chip. In FPGA, it stands for field programmable gate array. So let's understand the meaning of term specific application. It means that if you go to any company, let's say NVIDIA, they are developing a chip, or you take Qualcomm, they are developing a chip for mobile phone. That will only work as a mobile phone. Whatever Qualcomm develops, you cannot use it as a television chip. You cannot use it as a laptop chip. Even though there might be a lot of things in common, but you cannot use it because it is developed for specific to an application. The chip that they have developed is specific to mobile phone only. That chip cannot be used as laptop. Though that style of development is called as ASIC. Second style is called as FPGA, which stands for field programmable gate array. Same FPGA board can be programmed to behave like different applications. Like same FPGA board can be programmed to behave like a mobile phone, can be programmed to behave like a laptop chip. So in summary, in FPGA, same hardware can be used to behave like a mobile phone, same can be used to behave like a laptop, given that there are enough resources. I mean, my FPGA board should be having sufficient resources to implement this. Now, which one is better then? So going by this, FPGA is flexible, right? I mean, you're able to
FPGA.
use the same hardware for ASIC, I mean, mobile phone and some other application also. But as we go forward, we will understand that it is actually ASIC which is preferred by the industry compared to FPGA. Why? Because of the cost advantage. If I go for a bulk production, bulk means what? Manufacturing in a large quantities. If we are manufacturing in large quantities, ASIC will be cheaper compared to FPGA. In summary, if I have to manufacture a mobile chip, if we are manufacturing, let's say 1 million, how many mobile phone chips we are manufacturing? 1 million. ASIC will cost me roughly, let's say $15. How much per chip will cost in ASIC? $15. The FPGA might cost me $50. Same functionality to manufacture using FPGA board, it may cost me $40. So there is a difference, right? So in this requirement, what is that you will go with? You will go with ASIC because finally that translates. If the chip is cheaper, my mobile phone also will be cheaper. So it is easy to sell the phone in that case. Okay, if I tell that there is a FPGA board, buy it for another double the price, will you buy? As a consumer, you don't worry whether there is a ASIC or FPGA. Let's say you go to your father and tell there is ASIC in it, there is a FPGA in it. Will he bother? All right. People will only understand what is the cost, all the same features, same functionality. Will I get at a lower cost? So that is where for bulk production, what do we prefer? ASIC. For a less uses, limited production, we go with. You may say, where is the difference? Why in bulk it is cheaper? Why in smaller quantity? Why FPGA is better? We'll discuss that part. Though it looks like FPGA approach is better, however, industry prefers ASIC design flow due to low cost of manufacturing. If ASIC is cheaper option, why we don't do everything in ASIC? Question is what? If ASIC is cheaper, then why we don't do everything in ASIC? For ASIC, initial investment is very high. We'll discuss that part. Let's first understand what is the cost of ASIC design. Initial investment will be multiple $1 million. Means we need in ASIC, everything need to be started from scratch. You don't have any hardware to start with. You just have a concept that I have to manufacture a mobile with these features. That's all. You don't have any hardware, anything. Because of that, since you have to do everything from scratch, it will cost multiple $1 million. Once the flow is working, once you have set up the flow where you know how to manufacture one chip, per chip cost will be less. Initial investment is high, per chip cost will be less. What is the cost of FPGA flow? Lakhs of dollars or maybe less. You don't need to start with $1 billion. You can start with only less amount. Why? Because hardware is already there for you. You don't have to develop the hardware. Then you may say, then why this cost also? You need to have some engineers, right? I need to have some people who will develop the code, who will implement the design and all that. That is that cost. Then you may say, where is this cost is going? It is going for purchasing of the softwares. Purchasing of software. A lot of other things will be there. There, lot of money goes. But the problem with FPGA is what? Per chip cost is more. I mean, each board will cost more. So this is how the graph you see here. This is how the equation looks like. What is there in the x-axis? What is the x-axis represents in this? Volume means what? How many
Quantity.
units we are manufacturing?
Quantity.
Let's say mobile phone, how many units you want to manufacture in total? Okay, let's say 1 lakh, 5 lakhs, that will be the volume. What is this one? Y-axis. Cost. To manufacture those many units, what is the total cost? In case of FPGA, the initial investment is less. Initial investment is less. But per chip cost is high, so it is very slant. The per chip cost is high, so this very slant. Whereas in ASIC, initial investment is high. But per chip cost will be less. Because of that, you see it's like this. Do you see that difference? Let's say this number is 40,000. Just I took randomly. May I ask, how did you come with 40,000? I just took it. Somewhere here I want to manufacture 20,000. As per my requirements, what could be the example? I'll tell you. You know Boeing and Airbus, right? What do? They manufacture aircrafts, right? Does any electronic things go into that Airbus and all those things? Boeing? It goes, right? You need in flights, you need a lot of electronic system. When they want to manufacture, do they need to manufacture 1 million systems? Do you have 1 million flights in world? They may have to manufacture thousands only, right? Not 1 lakh also, not 10 lakhs also. How many flights some company will manufacture in a year? Hardly 100, 200, or maybe 1,000. Not more than that. Do you agree with that? In those cases, when they want to manufacture only 20,000, so let's say this is their equation. Will they go with FPGA or ASIC? FPGA. Why? Because the FPGA cost would be this much. ASIC cost will be this much. Which one is cheaper? FPGA is cheaper. Let's say you go to Qualcomm, they want to develop mobile phone chips, which will sell like 10 lakhs. So this same phone, if you take worldwide, it may sell almost 10 lakh units, right? Let's say that number is somewhere here. That number is somewhere here, or even very farther. Tell me which one will you go with? We'll go with ASIC because FPGA is way costlier. This is cheaper. So this is the difference between ASIC and FPGA. Any VLSI chip can be developed either using in either of ASIC or FPGA based flow. Decision is based on the overall cost. ASIC based flow, as I said, $15 per chip. These are hypothetical numbers. Don't think that this chip will cost $15. Like it is lot of factors decide how much the chip inside this will cost. Just I'm taking hypothetical cost. Okay, FPGA based flow, it may cost $50. Companies which manufacture products for bulk usage, they go for ASIC production. Example, mobile phone sells in millions of numbers. Tell me which company goes for FPGA based production? Yeah, defense aerospace, where you need in limited usage. Companies which manufacture for limited applications. Mostly the ratio is 85% is to 15%, or maybe plus or minus 5 number. Hardware used in flights sells in thousands only, right? Not in lakhs or millions. So based on that, the companies will decide. ASIC has some advantages over FPGA. ASIC has some advantages over FPGA. Let us discuss that. Can someone tell me what do you think are the advantages of ASIC? First advantage is what? Cost is the advantage. Second is what? It can be customized. It can be customized. Means what is meant by customized? If you take FPGA board, if it comes with this much size, you have to use that only. You cannot say that I'll cut it into 4 pieces. I'll only use this. Is it possible? Right? You have to use the entire board, and that you cannot change. You don't have any control on that. Whereas in ASIC, you can create this much small piece of. ASIC advantages are it's cheaper, consumes less die area, hence cheaper. It consumes less die area, hence it is cheaper. Provide flexibility to customize the design features, and it is power efficient. It can work at higher frequencies compared to FPGA. Is that clear to you? What are the advantages of ASIC or FPGA? First advantage is what? Cheaper. Second is what? Consumes less die area, hence it is cheaper. Third is what? Flexibility to customize. You can make it cheaper, smaller. You can customize the power consumption, customize the performance as you want. Fourth is what? Power efficient. Fifth is what? Can work at much higher frequencies compared to FPGA. This is actually very important. Very, very important. If I manufacture same thing with FPGA, it won't give me the same performance as ASIC. But FPGA also has advantages over ASIC. It's not like ASIC is always best. There are cases where FPGA is preferred over ASIC. What are those? Let's take a look. If the chip has a bug, which is detected after the manufacturing, we don't incur big cost. If you use FPGA flow, what you lose is just one board. In FPGA, if there is a bug in the chip, you will only lose one board. You don't lose millions of rupees. We don't have to implement the entire flow again. Let's say chip is there, if there is a bug, you don't have to implement entire flow because the board is already available to you. You just have to fix your RTL code, Verilog code, and put the new one onto the same board. Bug can be fixed in the next FPGA board. We don't need to start from scratch. In ASIC, if there is a bug, we don't need to do entire flow again. Second advantage is what? FPGA is quick because you don't start from the scratch. Do you start from the scratch? No. Hence, it takes less time. Since we don't start from scratch, board is already available. So time taken to develop the chip will be lesser. Amount of time taken is relatively less compared to ASIC. Actually speaking, even if some companies working in ASIC flow, they will use FPGA in between because they do something called as FPGA prototyping. Whatever I want to develop with ASIC, first I will prove that it is working with FPGA board. Then I'll go for the ASIC production. FPGA prototyping is used to check ASIC behavior before it is manufactured. What is FPGA prototyping means? Implement the logic on FPGA board and check the behavior. Before actually manufacturing the silicon wafer, you first try it on FPGA board. If it works, then you go for this process is called as FPGA prototyping. This process is called as FPGA prototype. Next, ASIC versus FPGA. Let us understand the difference between ASIC versus FPGA. Let's not go deep into it. Just understand that in this slide, what I'm trying to show you is smaller quantity if you are manufacturing, FPGA is better because initial cost is less. Here what I'm showing is if you are manufacturing bulk products, 1 lakh or 10 lakhs, ASIC is better. So any question so far? Do you understand what is ASIC, what is FPGA? Okay. So VLSI design flow for ASIC versus FPGA. I mean, if I take both ASIC and FPGA, where do they differ? Let's understand that. Let's now understand VLSI design flow for ASIC versus FPGA. VLSI design flow is similar for, actually front end domain is similar. Both ASIC engineer and FPGA, the front end domain is similar because in both the cases you have to understand the design, you have to develop the code using Verilog language. Whether you go with ASIC or FPGA, same thing. In both the cases, user need to understand the design specification, implement it using Verilog or VHDL languages. The third is functional verification of design behavior using SV and UVM. Where do ASIC and FPGA differ? Where do they differ actually? ASIC and FPGA. Majorly they differ in VLSI backend. That is where the very important difference comes. See, that's where the ASIC engineer customizes it. I mean, he will decide processor will go here, the display block will go here, the memories will go here. Like that he decides. That is called as customization. Customization means what? You make your own room, you adjust the things as per your requirement. FPGA is like it comes with a setting where you cannot do anything. Everything is fixed. You cannot optimize your room area there. Got it, right? So where do they differ? Backend flow. Because in ASIC, since you can do customization, lot of work will be there in ASIC. In FPGA, the work will be very less for a VLSI engineer. Physical design engineer, they will not have any much work at all. The flow starting from physical design to custom layout is where they actually differ. The way we do floor planning, power placement, power planning, CTS, routing, IR drop, that is where they differ. So where do all these things differ? In floor planning, placement, power planning, all these aspects. So let us quickly revise all the things that we have discussed so far. Where did we start our discussion with? We started off our discussion with understanding of mobile phone, electronic system, and what constitutes a electronic system, like hardware, the firmware, the operating system, and the applications. Then we understood how they interface with each other. Next, we understood the different styles of VLSI development. What are those two styles? ASIC and FPGA. Then we have understood the difference between ASIC and FPGA. I hope it is clear. Any questions so far? Let's do for another 10-15 minutes and go for a break after that. So now let us focus on ASIC design flow. Let's focus on ASIC design flow. So ASIC design flow, this is the analogy. Can you please read it once? So what does it start with?
Of application is it?
So as I said, it starts with the requirement. Like what do you need in the house? Whom do you go to? After that, you list down your requirement, you go to house architect. House architect, what he will take? He will ask you what is your requirements. Then what he gives? Various plans, architecture plan, plinth, electric, plumbing, different plans he will give. Then whom do you go to? You go to a contractor. So at different stages happens. See, the point I am trying to tell is whatever is the output of this stage, it becomes input to the next stage. What is the output of this stage? That becomes input to the next stage. You got it, right? So that is how VLSI flow also works. Can electrician do before architecture? Can plumber do work before contractor work? No, right? There is a specific order. That exact order has to be followed. Same thing happens in VLSI also. Okay. You have carpenter, painter, different people involved. So you see, the point here we are trying to understand is house cannot be constructed by one person. House cannot be constructed by one person. There are different people involved who collectively help construct the house. Same way in VLSI, one person cannot manufacture a chip. If it is a simple room, let's say small room, yes, one person can do everything. He can do the construction, he can do plastering, he can do carpentry work, everything. If it is simple thing. Same thing in VLSI also. If the chip is very simple, one person can do everything. But if the chip is complex, even if that one person is very good, he cannot do. Why? Because it will delay the house construction too much. Same way in VLSI also, you have different people for different roles. You have different people for different roles. Like for RTL coding, one person will be there. For verification, there will be one person. For physical design, one person. Then they coordinate with each other. Let's say I'm doing a construction. Okay, different people are there, workers. They don't coordinate properly. Then what will happen? It won't work properly, right? Same thing exactly. I mean, if you understand how house construction happens, similar thing can be correlated to chip manufacturing also. So similar to that, let's understand ASIC design flow. ASIC design flow also consists of 15 steps divided into two major categories. In ASIC, when you are manufacturing a chip, it has got how many steps? Around 15 steps, which are categorized into two major categories. One is front-end domain, one is back-end domain. So there are majorly entire manufacturing of a chip can be divided into two domains. One is front-end domain, one is back-end domain. Front-end domain starts with the design requirements, like the way how your house construction started with requirements, right? What do you want in the house? How many floors? How many rooms? All those things, right? Exactly same. In house construction, whom did you go to next? Design architect, right? House architect. Here you will go to chip architect. There will be a chip architect who will take your requirements. You will understand, okay, what kind of processor you need, what performance you need, what display you need, what kind of USB you need, what kind of audio you need. Everything you will understand. He will come up with the architecture. Then once you have architecture, whom do you go to? RTL design team. There will be a specific team called as RTL design team. Now, what does RTL stand for? Register transfer level. It is a style of coding in Verilog. Once it is done, see, these people will develop small blocks. Next person puts together everything, makes a process. That person who puts together everything is integrating everything, right? He is integrating small things to get a bigger thing. That person is called as RTL integration engineer. That work is called as RTL integration. You are integrating everything. What is the third thing, last thing, next thing? Once you have integrated everything, you have to verify whether it's working fine or not. That is called as functional verification. You are verifying the functionality. Then we do DFT, design for testability at the RTL level. We do design for testability at the RTL level. In summary, the process of chip manufacturing can be majorly divided into two steps. What are the two steps? Front-end domain, back-end domain. The front-end domain starts with what? Requirements, architecture, RTL coding, RTL integration, and RTL verification, functional verification. Then you do DFT. Majorly these works, they are very similar to software engineer role. What are the three things I marked? Design, integration, and verification. Three things. Design, integration, and verification is similar to software job actually. The person who gets into these roles needs a good programming expertise. Person who want to get into RTL team, RTL design, integration, verification should be good with programming. That means you may ask, should I be very good with programming before joining this course? Not now. When you get into the job, that time you should be. So our training will make sure that you become good with this expertise. Backend domain. It starts with an important step called as synthesis. Can someone tell me what exactly is synthesis? Synthesis is the process of converting RTL code to the gate level. Then DFT at the gate level. See, DFT is done at the Verilog RTL level also, gate level also. Then we do physical design, static timing analysis, custom layout, physical verification. Then GDS2 extraction. GDS2 stands for graphic design system. What is graphic design system? Is more like it tells you, see, if you take a chip, this is how chip you see, you imagine, right? Actually, it's not how chip is. It is a three-dimensional structure. Inside the chip, silicon will be there, right? It's all silicon. At one level, you do etching, then you deposit some metal, then you deposit oxide, then you etching inside. You're going into deep into the chip. Then you do some polysilicon deposit, metal deposit, lot of things you do. So this GDS2 file, graphic design system file, will tell where exactly is where to do the etching, where to deposit the metal, how much doping to do. That information it will tell for each and every point in the chip. Then when you give this file to foundry, TSMC, various foundries are there, then they will follow this information, they will manufacture this chip. You understand what is GDS2 stands for? It will tell you like a three-dimensional overview, what is where the silicon will be there, where the metal will come, where the polysilicon will come, where how much doping to do, where the substrate will come, where the base will come, everything it will tell for each and every transistor. You may say, it is very simple, right? It is very simple. Then companies need 80,000 crores, 80,000 crores to set up one such plant. $10 billion or even higher than that, or $20 billion. Then why it should be simple, right? It is complicated because you have to manufacture such 100 crore such things. In how much area? 1 square centimeter or even less. That whole 100 crore or multiple 100 crores has to go into small area. So that is what makes it very complex. Even a dust particle, you can see, sometimes you see, you go to the sunlight, you see dust particle. Even if that dust particle goes, it won't work. Small dust particle. What it will do is it will do some kind of shorting actually. At nanometer level, it can do shorting, right? Then it won't work. So it requires a very refined process and all that, clean process. That is where it takes a lot of money to spend that. Once it is done, once you have this file, you go for fabrication. After fabrication, you get the chips. See, if fabrication is done something like this on this kind of plate, they will do cutting of the plate. Each one represents one chip. Each one represents one chip. That chip need to be verified, right? Whether this chip is working fine or not, we need to check. Whether this chip is working fine or not, we need to check. That is called as post-silicon validation. Once the silicon is there, you are validating whether the chip is working fine or not. So once it is done, you do packaging. Packaging means what? Assemble everything, get the product. So then what you have is it started with requirements. It went through all this. This whole process takes almost 2 years or 3 years. It almost takes 2 to 3 years for this process to be set up.
Excuse me, sir.
Let us go for a break now. We will meet in
Excuse
10
me,
minutes. Around 11:05 we'll meet. 12 minutes. Okay. Once we meet, we'll continue with the remaining things, and I'll also take up some question and answers.
Okay.
Let's meet at 11:05.
This conference will now be recorded.
So before the break, we were discussing about ASIC design flow. So we understood that ASIC design flow can be majorly divided into two steps: front-end domain, back-end domain. So why is it important for us is because you have to choose the domain, in which domain you have to get into majorly. That's a very important part of your career. It's similar to after your plus two, you choosing, right, whether to go into BTech or which stream you want to get into. Something like this here. Okay. So I want to give you an overview of what is there in front end, what is there in back end at top level, so that you get to choose the domain which is right for you. Okay. So let us now talk about the front end domain. The front end domain flow is similar to software development. Even in software development, they start with the requirements actually. What is the requirements of a software? They'll come up with the architecture kind of thing, software architecture. There will be a software architect. Then there will be development team who develops the software using specific language, C or C++. Then they do the software testing. Similar to that, in VLSI also we have requirements. Then we have a chip architect, like we have software architect. Here what we have? The chip architect. We do RTL coding, like the person develops software coding, we do RTL coding. Then we do like the way we do software testing, manual testing, test automation. Here also we have different types of verification, like directed verification, constrained random verification. Different things will be there. So what I'm telling is they are similar roles, similar flow. For a software engineer, what is the skill set? Tell me, what do you think is the skill set? What skill set he requires? Programming, and what languages he needs? C, C++, Java, or some languages similar to that. They should be good at reading the software specifications. For a given software, what is that specification? They should understand. They should be able to develop algorithm, implement the same using C, C++, Java, or similar languages. Should have good programming skills. They should be good with the programming skills. VLSI front-end domain engineer should be good with programming or have inclination towards programming. Someone who wants to get into front-end domain should be good with programming, or you should have inclination. You don't need to be expert. Let's say if you ask me, I want to join front-end training, should I be expert in C programming? No need. You should be good. You should have inclination that okay, I can learn programming. That confidence level you need. Like we have C, C++, Java here. Verilog is similar to C. SV is similar to C++. UVM is similar to Java. Very similar actually. Lot of things are similar. If any of you say that I am expert in C++, by default I will say go for front-end domain. Because like C++ is object-oriented programming, SV and UVM are also completely object-oriented. Let's say if you understand the in-depth of inheritance, encapsulation, polymorphism, parameterized classes, pointers, let's say you're good, then you can directly go for these things. Because you'll find it very easy to learn this. Let's say someone hasn't done any programming at all. Because the college where you studied, you didn't have that opportunity at all. You didn't learn C also. Then don't think much about front end. It won't be good for you, because starting again from the very scratch will be very difficult. It will take more time for you to gain that expertise. Then which domain you should go for? Backend domain. Like a software engineer reads the software specification, hardware engineer reads the hardware specification, understands the design functionality, implements the requirements using various protocols. There will be some protocols in VLSI called as USB, PCI Express, DDR, AMBA protocols, various protocols will be there. People who want to get into front-end domain should be comfortable with these protocols, some of them. Backend is completely reverse. In backend, no need of this. No need of this. No need to even understand the functionality. No need of programming. Backend domain requires a completely different skill set. What kind of skill set do they require? They should be good with basic circuit theory. What is the basic concepts of Kirchhoff's laws to start with? Understand the concept of capacitance, understand the concept of parasitics, understand the concept of delays, concept of semiconductors. What is CMOS? What is substrate? What are the short channel effects? At that level of understanding they need to have. Then they should be very good with the tools. There will be some softwares we use in VLSI. You might have used sometime Cadence Virtuoso, something like that you might have used, Model Sim. So you should be good at using such softwares. That is the skill set required for back-end domain engineer. The front-end domain engineer requires more of programming related skill set. Back-end domain doesn't require any programming. It's more to do with technology, understanding semiconductors, fabrication, tools, all this. So where does VLSI differ from software? I said, okay, VLSI is similar to software. Then where do they differ? Software doesn't require backend flow. Software doesn't require backend flow. What is meant by backend domain flow? Process of converting Verilog code, like you develop Verilog code in a Verilog language. If you go to mobile phone shop and say, I want to buy a mobile phone, they won't sell you the Verilog code. What do they sell? Final product, right? That process of converting from this to this is called as backend domain flow. In software, it won't be there because in software, the code is used as it is. The application itself is used directly. You don't convert the application into a chip. In software, the code is installed and used. No need to manufacture as a chip. You don't manufacture the software. You install the software, use it. Let's say when you buy a software, does it come like a piece of hardware? You want to buy Windows Office. Does it come as a piece of hardware? No. It comes as an application that you install and use it. So because of that, in software, you don't need to do fabrication. Hence, software doesn't have this. In VLSI, the functional verification plays a very important. If there is a bug in the chip which is detected once it is in production, that is production means what? Customers are using. Like this laptop is in production. Okay, this laptop is in production. That is where I'm. So once the product is out and there is a bug in the product, you cannot do anything. You have to throw it off, do the entire flow again. In software, that is not the problem. Let's say in software, you go to bank. In the bank application, there is some bug is there. It can be rectified and they will release a new version of the software. Let me again repeat. You go to a bank. In the banking application, there is a bug. Because of that, some transactions are not happening properly. The company can rectify the software and can release a new version of the software. That is called as patch. In software terminology, it's called as patch. They're releasing a patch. In VLSI, there is no patch. It works or it doesn't work. Binary it is. Either works, either doesn't work. Hence, verification in VLSI is very important. Functional verification is very important because you cannot afford to leave any bug. In software, you're okay because you can still fix the patch, release a patch. Bugs can't be fixed in hardware. The entire flow needs to be done again. VLSI chips don't have a concept of patch. In software, if there is a bug, it can be fixed easily and can be released in a new version of the software. You understand what is the similarities and where do they differ? Okay. Tell me, what are the similarities between VLSI and software domain, front-end domain and software? Both are programming oriented. Both start from the specifications. Okay. Both require programming skills. Okay. These are the similarities. And both requires testing phase, where in software it is called as software testing. In VLSI it is called as functional verification. Whatever you call as software testing, in software it's called as functional verification. Why functional? You are verifying the functionality. Okay. Actually, then why don't we use term verification alone? In VLSI, there are 4 or 5 types of verifications are there. Power aware verification, timing verification, physical verification. In software, there is no multiple verification. In software, there is only one testing. That's all. Test the software. In VLSI, if you come, there are different types of verifications. Functional verification, timing verification, power aware verification, low power verification. Then you have physical verification. Because of that, we don't use the term verification. We use term functional verification. Got it. Where do they differ? They differ in the backend flow. In software, there is no backend domain flow. In VLSI, backend domain flow is there. In software, even if there are bugs, it can be fixed easily. In VLSI, you cannot fix, you have to do the entire flow. Yeah, Sai, what is your question?
In software, we call a full stack and all, right? Why don't we use
Any
a full
questions are
stack
there?
here? Am I audible?
So these are the different steps in the pre-synthesis. Requirements, architecture, RTL design, RTL integration,
Okay.
RTL functional verification. In backend domain, so the steps which starts from synthesis goes till post silicon validation. It's nothing new. Whatever I have explained previous slide, same thing. In VLSI domain, different job roles are there. Like I said, in house construction, the same person does all the work. For different role, there is a different person, right? The person who does the wood related work is the carpenter. Will he do plumbing? He doesn't even understand actually. The plumber who works, okay, if I ask him to do some carpentry work, he doesn't know much of it. Same thing in VLSI also. Let's say I worked in functional verification. Like I said, for 14 years, I worked in functional verification. I don't know how to do synthesis. Little bit because I tried once, I know. Because I run an institute, I know. Otherwise, if I was in the same job, I didn't know. Because I don't need to know. Why? I don't need to know. Even if I know, there is no use of my knowledge because nobody will give me synthesis work. They will only give me functional verification work. So in VLSI, it works in a choosing one domain and gaining expertise in one domain. You got it? It's like instead of having small knowledge of everything, okay, have a very in-depth knowledge of one very small thing. This diagram is in reference to the big trees. The trees which have roots spreaded like this, they will only grow this much. Okay. The trees which have very deep roots grow very tall. Point I am trying to tell here is that in industry, people don't want you to know a little bit of everything. People want you to be expert in one domain. Just choose one domain, be expert in one domain. It can be any domain. RTL coding, RTL integration, RTL verification, physical design, DFT, one domain, any one domain you should be expert. So what are the different job roles in front-end domain? Design requirements is marketing team. Architecture is design architect. RTL coding is RTL design engineer. RTL integration is RTL integration engineer. RTL functional verification is functional verification engineer. DFT at RTL level is DFT engineer. Synthesis is synthesis engineer. Formal LEC. So point is, many things you probably won't even remember. I'm trying to tell that these many different people are involved. When you use a mobile phone, you should know that there are these many people who have worked for this to happen. Okay. Now, this in software it was easy. Let's say you wanted to do a course in software. It was very easy for you. Why? There are only two things you have to decide between. What are the two things? Either you will become a developer or a tester. There is only two questions you have to ask: whether I want to get into development role or testing role. When you say testing, it involves both manual testing and test automation. So there is no confusion. In VLSI, the problem is there actually. Now, you can become a DFT engineer, you can become a physical design engineer, you can become a ST engineer, layout engineer, post-silicon, everything you can. You can choose any domain, and each domain has its own expertise and roles. But as a fresher, how do you choose? You don't know what is DFT, you don't know what is STA, what is physical design. How do you choose? That is where we tell to the students that first choose between front end and back end. Just only choose between front end and back end. As you go forward, you can choose the subdomain. Let's say you selected backend domain. Up to 2 months, you have option to move here, you have option to move here. That flexibility also you have, so that you should not regret. Let's say, for example, right now you thought, I'm okay with programming, you took it, but you don't like it. There will be a flexibility to switch to the other domain, no cost. If you ask me, what about after 3 months I want to switch, you can move, but there will be some cost will be there, because you have spent a lot more time. So that cost. Now, if you ask me, will I miss any topics because I'm switching? So what happens is, 1 month is common for everyone. Digital design, how to work with text editors, right? Typing thing, right? Some basics of Linux, they will all be common for 1 month. Where do these things differ is after 1 month. So you will be missing 1 month topics, right? Out of 2 months, how many months you will be missing? 1 month. That you join into the next batch. When you join into the next batch, you continue with that batch. So you basically lose 1 month. You get delayed by 1 month. But that is okay, because you are able to choose the right domain for yourself. You got the idea a little bit about what is front end, what is back end. So you right now, today, you don't have to think about, do I have to become physical design engineer? Do I have to become a STA engineer? You don't have to worry. Okay, there is still a lot of time. You still have 2 months time where you can still choose which domain you want to get in. Next, ASIC team distribution. Little bit about how a team distribution happens, so that you can choose. If a total team size is 50 people, let's say you go to Qualcomm, there is one team which is working on a chip, who want to manufacture this mobile phone chip. Okay, there's a team who want to manufacture this mobile phone chip. Let's say there are 50 people in that team. So how the distribution will be? Out of this 50, front end domain will have around 25 to 30 people. That's around how much percentage? 50 to 60%. So there will be little more people in the front-end domain compared to back-end domain. Out of them, how many architects will be there? Only one. How many people will be there in the design team? Around 4 to 6 people. Functional verification, 15 to 20 people will be there. So which is the team where majority of people will be there? Functional. Because it is a very important part. You may say, is design not important? It is also important. What happens in design is the companies buy the license and reuse such. Means if I want to manufacture a chip, I don't start everything from scratch. It's like simple example is I want to construct a house. I need wood. So I won't grow the tree and get it. What I will do, I will purchase the wood. Sometimes if I find it convenient, if the frame is available, I'll readily buy the frame itself. If at all the frame is available, I'll buy the frame itself readily. So frame will come at a little more cost, but I'm okay with that. Why? It will speed up my house construction. Similar example, let's say I purchase bricks at 10 rupees. Okay. Purchase bricks at 10 rupees. If myself gets manufacturing, I may do it in 6 rupees, but I'll still go with what? Understood, right? So in case of design, it works with reusing. Reuse means what? They can buy the existing thing and then develop. Because of that, you don't need a lot of people. But verification still needs people. Even after all that, they need to verify each and everything because you can't release a product with some bugs in it. Now, backend domain, how many people will be required? Around 20 to 25. DFT will require 2 to 5. Physical design requires 10 to 15. STA will require 3 to 5. Layout will require 3. It's a very rough distribution. Okay, don't think that. Then you may ask, where is the post silicon validation engineer? Okay, different roles, right? I just gave it rough estimate. Okay, so the point I am trying to tell is there are more requirements in functional verification. There are more requirements in physical design. It does not mean that you will not get anything in DFT, you will not get anything in, you will also get there. In fact, it's all evenly distributed. It means since there are more opportunities here, lot of people join these two trainings. Lot of people join these two trainings. Since there are lesser opportunities, very less people join DFT training. So hence, you don't have any disadvantage. Let's say you take DFT training, you don't have any disadvantage. Don't think that there are only 2 to 5. So I'll have disadvantage. No, you will also still get opportunities. Let's talk about the training schedule. Once this is done, I'll take up question and answers. Mode of training. First of all, training is available in full week. It is mostly meant for freshers who have passed out of the college or who are in the final semester of the college. Second is weekends only training. A possibility of weekday evening batch, but chance is less because if there is only 1 or 2 students, we don't do evening batches. We go with the regular schedule only. For 1-2 students, we cannot do dedicated batch. Full week training is available in 3 modes. Entire 100% online you can do, 100% offline you can do, the way we are doing now, and hybrid model. Hybrid means few sessions you come online, few sessions you come offline. There is no restriction. Today you are online, tomorrow offline. Next 1 month online, next 1 week offline. There is no restriction. Okay. Hybrid means partly online, partly offline. In this mode of training, in full week mode of training, you get recorded video access for 2 weeks for every session. Every session you attend, you can revise the topics for 2 weeks by going through the video. Sometimes it's actually kept even for 2 months also. But minimum commitment is 2 weeks. Means after 2 weeks, we have the right to remove it. But sometimes our admin keeps it even till 2 months also, till the end of that course. Let's say Verilog is started 1st of Jan, it goes till Feb end. Sometimes he keeps till Feb end, mid-March also. Weekend only training, currently it's all done online only. Because who goes for weekends only training? Working people. They mostly want to attend online only. Dedicated mentor for offline doubt clarification. Let's say someone is in Bangalore, but he is attending online. He want to come to institute for doubt clarification. He can come. We'll arrange a classroom doubt clarification. The good thing in the flexibility in weekend training is they get access to all the recorded videos for entire course duration. Here it is only for 2 to 3 weeks. Here it is for entire course duration. Evening batches, as I said, it depends upon the minimum participant. We need minimum of 5 people to run any batch. Irrespective of mode of training, every student has a dedicated mentor for doubt clarifications. Now, let us talk about RTL design and verification training. Most of you are here for this training. So as I said, it is the same domain. Design verification training, we can call it as ASIC verification training, we call it as functional verification training. Whatever term I use, it's all same. Let's talk about functional verification training. Functional verification training is a 8 months course. It is purposefully extended. Reason is, I know many institutes finish in 5 months or maximum 6 months. It is not sufficient to get a job. If you are already good with Verilog, let's say if you are expert in digital design, let's say you are expert in digital design, you are prepared for GATE exam, and you are very good with digital design. Then out of 8 months, you reduce 1 month, 7 months. You don't need to do digital design. Okay, because to gain expertise in one subject like digital design, it requires almost 1 month time. To gain expertise in Verilog, it will require 2 to 2.5 months time. Minimum. Anything less than that we do, we'll be doing only at top level. System Verilog will again require 2.5 months, 2 to 2.5 months. UVM will only require 1 month, maybe less than that, little less than. Totally, this whole thing will take 3 months. This will take around 2 months. Digital, 3 plus 3, 6 months. Okay. Digital design, Verilog, System Verilog, and UVM will require totally 6 months, maybe a little more than that. By then, you are ready for job. I mean, you don't need to wait till end of the course, end of 8 months to get a job. By 6 months, you start getting the job opportunities. Then you may ask, what is the remaining 2-3 months for? That 2-3 months is for doing the industry standard projects. That is where our course majorly differs from the other institutes. In other institute, what I have noticed is they will be in hurry to complete the course. They mostly try to wind up in 5 to 6 months. One of the reasons we analyzed what could be the difference is the training room facility. I mean, ability to run multiple batches confidently. We have enough rooms, 10 rooms to conduct many batches parallelly. Most of the places where I have seen 2 to 3 rooms will be there. Big rooms, well set up rooms, but in a 2 rooms you can only run 2 batches at a time, right? In 10 rooms we can run, and that's where we have the difference. So we don't hurry in completing the course. Reason is, you go out with half preparation. Let's say you get job also. So someone is not prepared well, they get a job. The first problem is faced by the company actually. The company who hires the person will face problem. They again take you through the training actually. They hire you, they again take you through the training. Second problem comes to you. They will ask you, how did you come without required preparation? Okay. Because they cannot teach the way training institute teaches, company cannot teach. Because company role is not training. Third problem will be for the institute. If you don't perform well, institute will get bad reputation. If you perform well, institute gets the good reputation. Simple, right? Your performance is what reflects the institute. So we thought Let's not restrict the number of months. Let's do a proper training. Even if it means 8 months, even if it means 9 months, we'll do. But the only thing we have made sure that by 6 months you start getting opportunities, job opportunities. You don't have to wait till 8 months, 9 months for entire training to complete. Start getting, because when you go for interviews, they won't really worry about the project part. They're okay if you're expert in digital, expert in Verilog, system Verilog, and UVM. They're okay. So how this 8 months is distributed? It's 6 days per week. Sunday is off. 4 to 5 hours per day, 9:30 a.m. to 1:30 p.m. and possibly after lunch hours. Sometimes the sessions can go after the lunch hours. How this 4 to 5 hours is distributed? 1.5 to 2 hours theory session every day, 3 to 3.5 hours of lab session. Every session, lab sessions are not recorded, theory sessions are recorded. That access will be there for 2 weeks. We have a platform inskill.in. It is our e-learning platform where you get access to all the course material. Let's say if I log in, if I go to Verilog, you get access to the videos. I mean, not these videos, the live batch videos. You get the schedule, how you should finish. The presentations you get, the language presentation, projects presentation, assignments will be there. All the assignments will be there here. The session notes and labs will be there. Don't think that it's a video course. Videos are only supplementary. We are just giving additionally to you. Every day, every session is done live, offline, online. Okay, you should not get confused that he's showing videos. That means, do I have to go through videos? No. Videos is only for additional revision purpose. Okay. So the point I'm trying to tell is you get everything in one place. Okay. All the course presentations, assignments, and notes are uploaded here. You get access here. Like that, for every topic you get things. Printed course material is provided for all modes of training. I mean, whether you are attending online, offline. If it is online, we send it by post anywhere in India. Okay. Offline, you collect here. Even in e-learning mode also, we send it. Next. The functional verification training is divided into 3 phases. Phase 1, which goes for 3 months. It covers, phase 2 is for 3 months. Phase 3 is for 2 to 2.5 months. During phase 1, we do advanced digital design, Verilog projects, majorly. Other than that, we teach GVim text editor. These are the things, 4 things we do in the initial 3 months of the training. Phase 2, we do system Verilog and UVM. Also, we do Linux commands and soft skill training. Placement support starts after 5.5 months of the training, or 6 months, I would say. So if you are good, you can get placement support after system Verilog itself. Just to give you a comparison, some other institute, what I have seen, they majorly finish system Verilog in 1 month. It's mostly they go through the presentations, which is languages are never learned by going through the presentations. Languages are always learned by practicing. You have to practice, as much practice labs you do, assignments you do, learn. The other problem where what I have seen in other institutes is they have labs already. They have some piece of codes. Many times you don't develop the code, you run that code. So you are under a wrong assumption that you are learning. Okay. Whereas you have to develop everything from scratch. That is where our focus. So So we won't give you any setup. We won't give you these are the piece of codes. Okay. We won't even make you sit in our system. You bring your laptops. If you sit here, you use this. You do everything from scratch. Then if you have a doubt, trainer will be there to clarify it. Phase 3 will do industry standard projects. Projects based on standard protocols like Ethernet, MAC, AXI, AHP. Python scripting also will teach. SOC flow. So how many phases are there in the training? Overall, 3 phases. Phase 1, phase 2 actually helps in getting the job. Even if you don't do this, many times you can end up getting a job. Let's say even if you skip this entire training, you can actually manage to get a job. Because when you go to a company, hiring happens based on your this expertise. Then why do we need to do phase 3 if you just getting a job is the purpose? Why do you need phase 3? You need because in industry you do this one. This is what you actually work. You work on a project. So there you need to know how the project flow works, how to start from the project specification, everything. So the phase 3 helps you perform in the job. Because I'll tell you one thing, once you complete this training and go, you'll realize that that is not useful at all. You'll realize that it only helped me get a job. What is really helping me is this part. Not today. You'll realize once you get a job and you start working, you'll realize the importance of this part. Next. Most all other institutes training stops after this. Most of the training institute, I mean whatever I have seen, because no one has time to run for 8 months, 9 months. Actually. Other institutes, they do a small project. The problem with doing a small project is it doesn't give you industry feel. Does not give you industry feel. Means unless see when you get into the industry, why someone hires you and pays you salary? They want you to work independently, right? They don't want you to go for small doubt, how to read this, how to develop this small piece of code, how to run this. They don't want that. This course will give you that exposure where how to do the things yourself. Similarly, experienced engineer training is there, which is for 6.5 months, 6 days per week, 4 hours per day. Similar schedule will be there. Training is divided into 2 phases where we do system Verilog and UVM. Only difference is for experienced, we do advanced course. For freshers, this is not required. For a fresher, advanced level of UVM is not required. Because if you try to learn too much more than what you need, you get confused. Okay. Otherwise, similar. These are all same. Everything is same. Only thing is, in experience course, there is no digital design and no Verilog. Instead of that, we have UVM advanced course. FPGA system design also divided like this. I mean, if we'll have a dedicated session, their trainer will give you complete clarity about FPGA course. Similar thing for DFT training. DFT training goes for 26 weeks, which is around 6.5 months, 6 to 6.5 months. Training is divided into 3 phases. The initial phase will be basics, digital design, Verilog, Linux, GVim, TCL. Phase 2 will cover the DFT specific topics. Phase 3 will cover advanced DFT topics like L-based, M-based, JTAG, boundary scan, IJTAG. They are all covered in the phase 3. And hands-on project will be done. This is about DFT. Now, why I went through quickly is when you anyway attend DFT demo session today or tomorrow, trainer will give you in depth of what all things are done. Let me just give you a very brief about what is DFT. For the people, DFT stands for Design for Testability. So what happens is, once you manufacture a chip, inside this mobile there is a chip. It is manufactured at what technology? 7 nanometer, or 10 nanometer, which is very small actually. Inside that, if there is a small bug is there inside the chip, looking at the chip, I cannot tell that there is a bug. Okay. For example, you buy a laptop is faulty, some problem is there. Can you tell by looking at the laptop? So when will you come to know? When you start using. Same problem can happen in the chip. Inside the chip, there will be a problem. How will you check whether this chip is good or not? You apply some inputs. Apply some inputs to the chip. If outputs are coming as per your expectation, it is good. It's not coming, then it is wrong, fault. The person who generates these inputs, what inputs to apply? Okay, let's say to check laptop, you randomly do you start banging the laptop? No, right? You start doing some meaningful operation, right? That pattern, how will you check the chip? That pattern is provided by the DFT engineer. They are called as test vectors. The patterns are called as what? Test vectors. Those vectors are generated by whom? DFT engineer. DFT engineer gives, these are used by post silicon validation engineer and he checks it. So let's not go into physical design training and all those things because tomorrow demo session is focused on physical design. So now comes to the next part. How do you choose the right course? First thing is you should look at three kinds of expertise. You should think from three kinds of expertise. You should go for functional verification if you are comfortable with programming. Like I said, you are good with C++, very good with C++ or Java. Okay. Or someone is working in, let's say, already working in a software job. He want to switch to VLSI. They're already good with C++ Java. They should go for functional verification. It has a good job opportunities. Second, you can choose FPGA system design. Here also opportunities are there. It requires medium level of programming expertise. You don't need to be expert. You need some programming, definitely. But expertise of working with tools. Here also job opportunities are there. You may say, how can there be jobs? FPGA is very less. Means amount of work that happens in FPGA is less. Then how can there be good opportunity? The advantage is with very less people join training. In FPGA, overall in a year, throughout India, 100 people only will get undergo training. India means Bangalore, Hyderabad, Noida, different locations you take. Maybe around 100 people would be undergoing training. Because of that, you still stand a good chance of getting a job. You got the point I'm telling. In ASIC, it's reverse actually. 5,000 people undergo training. Maybe 3,000, 5,000. So the point is, so that way you can choose FPGA also. There's no problem. My work is functional verification. Okay, don't think I have any reason to motivate you for FPGA. Just telling you choose the decision accordingly. Because if everyone takes functional verification, what happens? Will everyone get jobs? No, right? So you have to choose the things after looking through all these things. Less number of engineers are available for hiring in this domain. Less number of people are available, hence you stand a better chance. So I won't tell you that 100% you will get a job. There is no 100% anywhere in this domain, any domain for that matter. There is a good chance. It is all in your hands. If you do well, if you put effort, in any domain you can get a job. Third is backend domain. In backend domain, like physical design, DFT, STA, custom layout, it requires no programming expertise. You don't need any programming at all. It's mostly tool and technology oriented job. It's mostly the tool and technology oriented job. So these are the three decision making. Basically, you would start off with analyzing your own skills. If you feel that you are comfortable with programming, You start with, you can take front-end domain courses. If you don't like programming at all, you go for backend domain course. Somewhere in between, you're okay, little bit programming I can do, then you can go for FPGA system. The good part is, whatever domain you choose, you can always switch within 2 months to other domain. We are not going to question, we are not going to charge anything additionally for that. The course flexibility, join any course, as I said, switch to any other course in 2 months, no additional fee. There's no need to repeat, as I said, right? Initial 1 month is common. You only have to rejoin the next batch of the different training. So how about preparing for job? Okay. What is the difficult part of training at any institute for that matter? Not just VLSIGuru Institute, anywhere. What is the difficult part is, things move quickly actually. Means like in your BTech, digital design is done for one full semester. I mean 4 hours, 4 hours per week. Here, instead of 4 hours, we do 20 to 25 hours per week. Only digital design. Okay. And the whole digital design is finished in 3 to 4 weeks. There you have to be very focused on that topic. Then Verilog will start. Whatever you did Verilog in your one semester, we do lot more in our course actually. Let's say you did very basic things of Verilog in your BTech. Here you do in lot more in depth. And it is finished in 2 months, entire, including many projects also. So that is what I mean by things move quickly. The second part problem, where the major problem, you remember, note down also, write down also. The second problem where every student faces problem is, let's say digital design is done in January. The training completes around August, for example. He forgets everything done in January. You can't go to interview and tell that I did in January, so I don't remember. You can't say that Verilog I did in February and March, so I don't remember. So you have to plan your schedule in such a way that you have to keep revising the things, keep practicing a little bit. This is where 95% of the students fail. If someone doesn't get a job, it's because of this. So while someone is doing digital, they are good with digital. So today I'm teaching multiplexer. I'm teaching some latch. I'm teaching some flip-flop. Today you are good because today you are doing subject. After 6 months, you don't remember the subject. Company won't listen, right? If I'm taking your interview, will I listen all that? Right? Either you revise or you remember the fundamentals, how to develop it. Either you remember that, you revise the things, or you remember the fundamental concept from where you will come up with the concept. Okay. So this is the major problem everyone faces. Now we keep telling that spend in a week 2 hours in a week to revise digital design, 2 hours to revise Verilog. Okay, that way you are in touch with the subject. Somewhere people fail there. Somewhere people don't plan properly. So the two problems are there. Things move quickly. That is also not a real. This is also not a big problem actually, because we give enough time for each topic. We give enough. That's why the training goes for 8 to 9 months. The bigger problem is what is done 2 3 months back. Now people don't remember. You may ask why it doesn't happen in BTech. Because in your BTech, all courses are spread over entire semester, so you are essentially in touch with the subject. But here, once digital is done, we will never revise digital unless we do some interview sessions. So that is where student has the responsibility to revise. If you don't get a job, this is the reason why you don't. If someone is not getting a job, even after doing well in the assignments, it is the reason. So why I am telling repeatedly is, doesn't matter whether you join here or anywhere, you have to remember this point in mind, that I have to keep revising the topics. I cannot go to interview and say that it was done 6 months back, so I don't remember. You cannot tell that, because they have another 10-15 options to hire from. If not you, they'll hire another person. So 8 months of training is very similar to the amount of knowledge you learn in 2 years of your BTech. That much depth subject will go to. As I said, your 3 weeks, our content is a lot more in depth. Reason is BTech you do mostly for getting the percentage. Your BTech degree mainly doesn't translate into a job. Completion of BTech doesn't automatically mean getting a job. You get a certificate with percentage of score. Okay, even for a college, they are okay looking at percentages. Whereas for an institute, we don't run the course because we want you to get 90%. Does it matter for me whether you get 90% in course or 95%? What is matter for me? You should go to the job, you should perform there, right? Then only everything is good. Company is happy, you are happy, and institute also will be good. So for that, we can't focus on the percentage. We have to make sure that everything is done practically. So that is how. So we, because of that, we go more depth into the subject. Each subject we go more deep. Okay. Like that, every topic. Okay. Now for you to get a job, little bit planning is required. You don't need to do any research and development. You don't need to innovate any new product. Simple common sense is all required. A simple common sense is all required. What is that common sense? A good 6 hours of effort per day, including the session time. Let's say you spend 4 hours in a session, another 3 hours, 2 to 3 hours, you spend from your side at home, and you plan your revision accordingly. Digital design is done 3 months back. No need to revise everything. Take some 10 questions, revise. Next week, take another 10 questions, revise. Very long, another 10 questions, revise. Keep doing that. You keep continue to be in touch with the subject. You get it. So simple common sense is that per day I'll spend 6 to 7 hours regularly. I'll maintain a notes. I'll keep revising the topics. By 8 months, 100% you have it. Now, then why people don't get a job? They miss somewhere. Actually. They don't revise. They don't do this. Third major reason is their fundamentals are very poor. What is fundamentals means? I'm not expecting digital and Verilog. Basic aptitude is very poor. Aptitude means what? A simple example I'll tell you. 5 people can do a job in 4 days. How many days it takes to for 10 people to do same job? 2 days. Okay, since we increase the number of days, 50% of people cannot answer this question. Who join our training? No, I'm not joking. I'm telling 50% of the people find it difficult to answer this question. So for that person, getting a job is very difficult. Making us get him job is very difficult because their mind is not matured to pick up the concepts. So there we suggest that before you start the training itself, you improve your aptitude skills. Just sit, do 1-2 months of aptitude book, come up to a level where you are able to correlate some question. What is the knowledge required here? I mean, this is very simple for that matter. Okay, so I would have rather said one man, two women did for some 5 days. I will complicate the question a little bit. Okay, 2 men and 3 women did for, let's say, 3 days. Now I'll ask one man and one woman how many days it will take. This lot of people will find it very difficult. My point will be, this much knowledge is required, this much basic understanding is required for you to understand. See here, what is this question is about? Ability to understand that there are 3 variables: number of men, number of women, and the work, amount of work. Then how coming up with how much work one man can do, how much work one woman can do, then accordingly calculate. This much minimum expertise is required. Whether you join here, whether you join another institute, nobody can do wonders. Okay. What can be done is They can teach you in a proper manner, but for it to be done, you need to have that minimum foundation is required. So my suggestion is, sincere suggestion, don't be in hurry to join the training. Okay, you just go to any good quantitative aptitude interview paper. I mean, just you attempt a mock test, you score 50% less, don't join the training because you are not ready for the training. At least 50% you should score in the limited in the given time. Then you can say that you are ready for the training. Okay, you got what I said, right? I'm telling in best interest of you, because you spend another 2 months. That's very good to improve your overall mathematical skills or basic aptitude skills. Then once you are up to this level, right? See, once you can correlate, okay, men, women, time, speed, distance, and speed, all that correlation you can do. You can draw the same knowledge for digital design. You can draw the same knowledge for Verilog programming, system Verilog. That will definitely help you. If you don't come with that foundation, you don't know whether to learn Verilog or whether to learn basic aptitude. And for us also, it's very difficult actually. So please take these two things seriously. What are the first suggestion I gave? You have to revise the topics. Anytime you don't revise, you will not get job. 100% you will not get job. 100%. Because even I don't remember. Let's say I did one training on something, some protocol. Okay, 6 months back. Now if someone asks me that protocol, I don't remember. Some fundamentals I know, but in depth I don't know. So even I have to revise, right? Same thing for you also. You have to make a notes and keep revising. Second thing is, make sure that you are good with the basic aptitude fundamentals. Basic aptitude. You buy a book, you keep a target like 1 month I have to finish stuff, or by next batch I will join this training. By April I will join if I am not good with it. You spend only your full time only doing aptitude. Come up to one level where you are fine with. Well, you will come up definitely. I mean, see, uh, as you start doing, you are basically you start improvising with your skills. Then you will see that you will feel that you are ready for this course. These are the two suggestions. And the other thing is what you have to spend minimum time. Without spending time, you cannot do anything. Okay, let's say I have to offer various courses, for example. Without time, I cannot give a quality training. I have to spend time, I have to prepare my own notes, I have to plan my presentation, all that, only then I can do good training. Same thing for you also. These are the few common sense things you have to just keep in mind. By 8 months, you get a job. It's not like there are no jobs, there are jobs. It's about how do you plan your preparation and having that right attitude and aptitude. We do performance tracking. Performance tracking is like we divide the students into multiple categories: good performer, average performers, poor performer. It is not to put into different classrooms. It is to make sure that you get the required support. Let's say you are not performing well, we will tell you what kind of support you require. We try to arrange some additional sessions for you. Okay, these days we started taking parents' phone number to intimate them that your son daughter is not spending enough time. The actual major problem we face is with that students don't spend time. Students don't have that motivation. They think that just by joining an institute you get a job. It doesn't happen at all. 80% is in students hand, 20% is the institute gives you the right direction, right knowledge. Okay, so recently we started doing that, where we started collecting the parents phone number, so that if student doesn't behaves very negligently, doesn't come to the class, doesn't submit assignment, any assignment at all, doesn't even attend any test, doesn't take any mock interview, then we inform the parent. Because finally what happens is parents call us, my son has joined, very, what is the job status? Okay. So we thought that would help. Now the purpose of this division of good, average, poor is to make sure that you get that required attention. If you are good, how additionally we can support. If you are average, how can you bring you to the good level? Okay. We track your performance based on the assignments. Lot of weightage is given to assignments. I'll tell you one thing: if you complete 80 to 90% of the course assignments, you will feel confident yourself that I can get a job. You won't even come to the institute for support. You won't even ask me that get me job, you will know that you will get a job. So that is what we want to do in the training. I don't want to give you a job. I want you to enable you to a position where you know that you can get a job. Okay. Right now you are not ready for that because your knowledge is mostly theoretical and more focused towards BTech subjects, but industry requires a different skill set. Okay. For assignment completion there will be lab sessions. It's not like you only have to do, the trainer will guide you. 10% only for attendance. I won't even bother whether you are here or not. I'll only look at assignments, how well you do in the assignments. Then 20% for evaluation test. Every month there will be evaluation test for every topic. 10% for presentations. We make you do the presentation. We give you a topic, you have to prepare a small presentation and you have to give the presentation. 10% for mock interviews. Means this presentation and mock interview is like a gradual improvement process. First time you may not do well, second month, third month, like that you gradually improve over the time. And we will create one dedicated WhatsApp group for every student where you can get the support. Let's say you are going through something, you need some support, you post that request in that dedicated WhatsApp group and our trainer will support you. Okay, in that group, trainer, admin and students are added. What is the final goal of 8 months of training is student should be enabled to work in the job independently. This is the goal actually. What is the goal? Student should be enabled to work independently. Work in the job independently means what? You go to job, you don't want to go to your senior, okay, for every small thing. Where to find this, how to open this file, how to run this. Because if you do that, they will get irritated because they have their own work. Okay, then why they hired you? Because you will do that work. If you make them do everything of yours, then that will be a problem, right? So you should be independent. Okay. That is a collective effort. Institute alone cannot do, student alone cannot do. It's like mutually it has to be done. Then only you reach that point. That's the final goal. So assignments, evaluation test, presentation, mock interviews, they're all in that direction. They're done to for you to achieve that. Today, if I ask you, are you ready? Probably no. But after 8 months, if you put regular effort, you will definitely reach there. What are the course prerequisites? Only one prerequisite: good quantitative aptitude. I'm not good with English, no problem. We will have a soft skill training where trainer will teach you uh, basic communication skills, how to attend interviews. That also will be done. Every week there will be 1 or 2 hours of session. Oh, every week it will be there. Okay. Student should have what is meant by quantitative aptitude? Basic ability to understand the problem. If I give you a problem, convert it into variables. Like I gave that men women work example, right? How do you convert it into few variables and how do you make the equations and solve the equations? That much basic understanding is required. Should be able to do basic logical analysis. Okay, as I said, if take a test, if you score less than 50%, don't take up the training immediately. It's okay to delay the training by another 1 month, 2 months, 3 months also, no problem. If you are good, if you are very good with the subject, even at 40 years, people get job. If you are very good with the subject, you get a job at even at 40 years in VLSI. If you are not good, whatever is your age, nobody will give you job. So better to build that foundation properly. What is the foundation? Only one foundation I am asking. No need of English, no need of any digital design, no need of Verilog. A good quantitative aptitude. Yeah, I think that's all. Now we can go to question and answers. What is the skill set required? We'll cover all the things. So all that I'm telling is, though I have listed down a lot of skill set required, We will teach everything. Whatever is required, we'll teach from basics. Reason is people come from different backgrounds. Someone comes from a college which is in Bangalore, which is in Hyderabad. Someone comes from a college which is in village, a town, small towns. There they don't have that much exposure. So we don't make any assumptions. We start from very fundamentals. Everything. But the only thing, as I said, is things move quickly. By the time you realize digital design is over, so you have to spend that time every day. Except for that, things are. Yeah, that's all. So I just listed what is the skill set required, but I have at top level I have told you, right? Front end requires programming kind of skill set. Back end requires non-programming tool and technology skill set. You require. Choosing the right domain, preparing for job, all those things. Why VLSI job is good? Why VLSI job? Work satisfaction. There are a lot of opportunities. It is limited to limited set of people. I mean, not everyone can try for VLSI job, whereas software jobs are open for many people, many domains. Okay. Uh, there is no significant requirement for reskilling. So this is very important. Means, please read that. So point is, whatever skill set I started my career in 2005. So whatever skill set I have in 2005, around 2007, like that, I learned system Verilog. 2009, I learned UVM. That is when UVM came around. Okay, whatever skill set I have, that I don't have to redo everything because the chip manufacturing flow doesn't change. Let's say how the house was constructed in 1990 and 2020, it's all similar, right? They don't do something else separately. Yeah, you got it right. The way house construction is not changed much. Some new technologies have come little bit. The same thing in the chip design flow also. Things don't change drastically. In software, the problem is new things keeps coming. Today it's AI. Sometime back, people used to call data science. Sometimes people used to call big data, Hadoop. Before that, .NET, Java. Before that, mainframes. A lot of things were there. Here, you don't have to reskill significantly. In software, if you don't reskill, you risk losing job. Here, one time you put effort and you learn the subject in depth, same concept will be there. Again, let's say someone did DFT in 2005. Then also techniques were same: scan, ATPG, BIST, JTAG, boundary scan. In 2005, even in 2025 also same techniques will be there. Just the way things are done will improvise. So significant reskilling is not required. And VLSI is a well-paid jobs. They are very among this set of jobs, software, embedded, VLSI is a high-paid job. Yeah. So I'm done with the demo. Any questions you have now? Yeah, Mayank, what is your question?
Sir, actually, in the duration of demo, you told that if anyone is opting going for a career in VLSI,
See, I can't explain in a language other than English because it's a common understanding for everyone, right? Okay. Someone is asking, please explain in Telugu. That's not possible.
no, sir,
VLSI. Yeah. Okay.
I
And
am
now I
speaking in
think
English.
if you have any question, please post all your questions now.
Okay.
What is the job security?
Job security. Uh, if you see job security from what perspective? Tell me.
Like, you have a 14 years of experience, right?
Yeah.
Now you are running your institution.
Yeah.
Then,
Please tell me. Yeah.
yeah, like I'm not getting it. Like, is there any pressure?
Why I am running institute? You're telling. Okay. What is date today? It is. If I earn 1 rupee there, I earn 5 rupees here. That's all. Simple. There is a pressure, of course. In job, there is a pressure. Here I am the boss. I'm in my building. I'm the king.
Yeah.
That's all. I mean, it's. I mean, now I can take off tomorrow for next 1 week. I'm not answerable to anyone. So I have my own reasons. Any- Uh, so anyway, it's more than money. It's about I started teaching parallelly, so I liked it. Then I found that salary wise and all things, it was okay for me to quit the job. Okay, the income levels are very high as a trainer. I mean, when I do corporate training, I get 50,000 in a day. Okay, it takes a lot of days in job to get that kind of salaries. Okay. Yeah. So there is no job security or anything. It's all about personal preferences. Yeah. Any other questions? Um, are the recordings available for lab sessions also? So tell me, what is the purpose of lab sessions? To help students do it. Tell me, will I be doing coding, or you will be doing coding? Students will be doing. Can I record your videos, what you are doing? Let's say there are 20 students. Can I record 20 students coding? All right. Purpose of lab session is to support a student is doing. Trainer will go to them, support with the queries. Now tell me, does it make sense to record that lab session? Right. I will only be talking. I mean, not me. My trainer will only talking. Are you stuck here? Okay, I'll support you. So there is no point recording that, uploading it. But whatever I teach, I do, we record and we give. That is the theory sessions. Theory means we do, I do practically also. That part will be given. So hence, that is the reason lab session recordings are not given. My mobile number is, okay. You can message me. Please, instead of calling, please WhatsApp me. That will be preferable. Okay. If there is a requirement, then we can go for a call. How to access lab VNC? Can you show example? Okay. So generally what happens is, once you register for the course, uh, at the right time you will be given VPN credentials. Okay. So once you get the VPN credentials, you connect through this one. The admin will explain you how to connect and all that. So once you connect, there will be one application called as Putty. Simple application you download, and our admin will help you. There will be some server number. You log in, you will be provided. Let's say my login is Srinim. Okay. We'll give you the login and password. You create a VNC session. You have to create something called as VNC session. My session number is 15. You see, what is the number you see here? 15. So there will be one VNC viewer will be there. Once you create a VNC session, you have to you have to view that session. So what is my number? 19 server, 15 number. On 19 server, 10.0.0.19 server, my session number is 15. Right? I enter password. I get the session. Now here you create a terminal, open a terminal. You have to do few commands. Then you can invoke the tool. I can run the commands here. VLOG, whatever commands I can run. So it's all take this much effort. It all takes this much effort only for you also. From wherever, as long as your internet connection is good, this is how it works. Any other questions? First, let me take down the questions. So I hope I have listed down all the questions. So I've shown you till third question. Next, let's go to the fourth question. For weekend trainings, are classes contentless? Also, will weekend training also start from basics of digital and Verilog? In weekend training, what happens is we give access to all the recorded videos. Sometime back I showed you videos. Each and every topic in detail will be there. Let's say Verilog language evolution, implementing combination logic. Each topic video will be there. You go here, you play that specific video. Right? Each and every video will be properly organized. Okay. In weekends, we cannot do 8 hours of training. Right now itself, you may be thinking when the session will get over. Right? If we started at 9:30, beyond 1:30, you cannot sit. Okay, I don't know how some institute does 8 hours of training. It's not possible actually. As a trainer, we cannot teach. You go and sit yourself, you can do another 3-4 hours, but you cannot keep listening to some person for 8 hours. Correct, right? So we can't do 8 hours on Saturday, Sunday. The people who enroll for weekend training is what already working. If I do Saturday and Sunday also, when they will have their personal things. Hence, we do half a day training on Saturday, half a day training on Sunday, at least for this domain. Okay. So that is where we give access to all the recorded videos and we do quick support session or revision sessions on Saturday and Sunday. But the main support point will be you will be connected with a dedicated trainer with whom you can connect anytime you need support. Let's say you don't need to wait till Saturday and Sunday. You can get the support even on Monday also because there's a group created where you get all the support. I mean, what is the group I'm talking about? If I go to, let's say, for every student, let's say 8356, let's say, it is a student who enrolled for physical design in December 2023. EL means e-learning. This she has enrolled for physical design in December 2023 e-learning. Her ID is 8356. So here she posts the support request. Whatever is support request, she posts here. Then our trainer will respond accordingly. Let's say for every student, Vandana, she has joined for DFT course in September 2023. So she can post the support request here. I mean, this is how each student support request is addressed. So in this group, trainer will be there. Among these 7 members, only one student is there. Remaining 6 are all our institute staff. Some are trainers, some are admin. So one of them will provide the required support. Like this, it is done for every student actually. Okay. It could be a small course which goes for 2 weeks. It could be a course which goes for 8 months also. But for every student, one group is created. So then it's about the student to take how much support they want to take. At one point, what happens is institute will keep asking you, do you need support? You are not doing well. I mean, we will arrange backup sessions or whatever. Okay, attend interview. Why you didn't attend interview? You didn't do well in evaluation. Why you didn't do well? After few months, we give up. Means okay, let student wants that only, you leave it. But if you want to get the benefit out of the institute course and institute facilities, you get whatever level you want. Okay. So I think the question was related to weekend training. I answered that, right? The training will start from digital and Verilog, but it will be quick paced training. You have to more dependent on the videos. Trainer will give you the topic schedule and he will cover those topics in the weekends. Sometimes in the evenings, weekdays evenings. Next, would you suggest to move from software? Next question. Would you suggest to move from software to VLSI? If yes, what course would you suggest for software experience candidates? See, would you suggest depends upon, let's say you are working in Wipro, HCL, TCS, Infosys, or Capgemini. In what are these companies? These are the companies who have what is that? VLSI division in them, hardware division in them. If you are working in any company which has got a hardware division, then it's very easy for you to move. It's a Tech Mahindra is there. Another 3-4 companies will be there who has both software and hardware division. In those cases, you can easily move. Let's say you are working in JP Morgan. What is JP Morgan? Some finance company. Do they manufacture chips? Do they have any hardware division? There it's difficult to convince. In Wipro, you can say that I was in a hardware team. Nobody will even question. So if you are into any of these companies, yes, you can blindly move because your experience will count there. But if you are in some non-VLSI domain, purely software, purely finance, something else, then difficult. I'm not saying no. I told you now, right? Sometime back, even at 40 years, if you are expert with the subject, you can get a job. Because private jobs always works on the skill, not on the any other factor. Government jobs have some other things, recommendation, lot of other things. Private jobs purely work on the private sector. Hiring purely works on the skill. Whatever be your age, if you are able to perform, company will hire. So again, what course would you suggest? As I said, if you are interested in programming, go for front-end domain. If you are not good with programming, then go for backend domain. Can an ASIC front-end engineer working in the industry switch to FPGA vice versa? It is very much possible. Just that before switching, you have to gain that expertise. You have to gain FPGA system design expertise. It is possible. During demo, you told that for functional verification, a candidate can have coding background in C++ or Java, but I have basic knowledge of C programming with good knowledge of microprocessor assembly level programming. Can I pursue verification, functional verification? Yes, you can pursue. See, all I said is you don't need to be expert. Did I say you should know C++? No. I said you should have that programming inclination where you have confidence on yourself that yes, I can do. I'm okay. Given some time, I can learn. Even today, what I'm telling is you don't need to know C programming also. If I tell you that, okay, I'll give you 2 months time. Are you confident about learning C language? Your answer should be yes, I can learn. That much confidence you should have. That's the only thing. Otherwise, you don't need to know anything. You can still learn it. We have worked, eighth question, if you have worked in some other domain in VLSI for 4 to 5 years, can we switch to functional verification? Tell me, what do you think should be the answer? It is possible. Only thing is, you need to gain expertise to that level, at least to work at 2 to 3 years experience. Because if you are working at 4 to 5 years experience, let's say possibly your salary is, let's say, 20 lakhs per annum, for example, or 15 or 20, 25, whatever it is. When you go into some other team and you start working as a fresher, can they give you 20 lakhs per annum? All right, they won't give you because business is all about money. Let's say Qualcomm is running, they don't run because they are a charity. They are here for business. They will count everything. How much salary is given to you? How much work do you do? If, as a fresher, if you do, they won't give you. They will reduce your salary. So you have to gain that expertise. That is where you upskill yourself and switch to the other. Understood, right? So it is possible. If you ask me, is it possible? It's possible. So what should I do in that case? You have to either learn yourself the new subject, or you undergo some training program where you gain that expertise, and then once you are ready, you switch for that. What about current job opportunities? Like recession is going on, companies are not hiring freshers. Okay. See, recession, the boom is all part of the cycle. Recession and everything is part of the cycle. You can't control, I can't control, nobody in the world can control. It's all part of it. Only thing you can do as a fresher is you can positively, you should keep preparing. That's it. If you ask me today, are there no job opportunities? There are. 6 months back, it was very bad. 6 months back, it was bad. Today, the situation has improved. Okay. Now, companies are not hiring. That won't happen. Companies will hire. My analysis, based on my limited understanding, is very unrelated to VLSI. As long as cheap oil is available, cheap energy is available, jobs will be continued. Till the time we have petrol and diesel at cheap cost, jobs will continue to be get created. Once we have that exhausted, everyone will suffer. Till the time, because cheap oil, what it does is it creates the opportunities. It creates the employment opportunities. If as soon as that stops, all the jobs, everything, world is crashed. Okay. Till the time, you don't have to worry about the job. Till the time energy is available cheaply, you don't have to worry about the job. Jobs will get created. If not in VLSI, some other sector will come which will create the jobs, because energy is available at a cheap cost. That's the only point I will say. So you should not worry. Yes, recession could be there, but you have to look at 6 months down the line, 1 year down the line, something new will come that will definitely create the opportunities. You got it, right? So people may say artificial intelligence will come. Let it come. Whatever skill set you learn, that will enable you to get job in that domain also. It's not like you will be only suitable for this domain after giving this time. If at all, let's say in the worst case you have to move to that domain, you can move that there also, because the course will enable you by overall improvising your skill set. How do you look at a problem? How do you understand the problem? How do you develop a code for that? Or how do you solve that problem? That approach is what you gain here. Okay. Next, are the lab sessions there in weekend classes? Yes, lab sessions will be there. The mostly Saturday and Sunday is focused on lab sessions only. The trainer will give you schedule. This week we'll do these topics. You have to go through those videos. Trainer will tell you these are the topics. You go through these videos. You go through that videos. Over Saturday and Sunday, trainer will do the lab sessions. I heard that for weekend batch has morning theory and afternoon lab. Is it possible? It is for physical design we are doing currently. Physical design and BFT has this schedule. Layout has this schedule. The schedule is for physical design and layout, where we are doing morning theory, afternoon lab session. For functional verification, we have been doing only 4 hour session. We are not doing entire day session. Okay. Only 9:30 to 1:30, that kind of timings only we are doing. Does having gap of 2 years affect my job opportunity even I'm prepared VLSI subject? There is no problem at all. 2 years is nothing actually. 2 years is nothing. People get job with 10 years gap also. Okay, but only thing is, as long as you are good with the subject. Uh, Now, to prepare to that level, you should do passionately. A little bit of planning. I told you, right? What is the planning? Whatever topic done, don't forget it. Keep revising. Make a notes. Okay, and just follow the basic schedule of 6 to 7 hours a day. And whatever trainer does, just do that. By 8 months, you have a job. 100% you have a job. What protocols are taught in the course? Does help is given in implementing making project related to that protocol? Yes. What protocols are taught? APB, SPI, AXI, Ethernet. These kind of protocols will be. These are the protocols that will be covered. Every session will have a supporting lab session. See, our approach is during the initial part of the training, you get more support. For each and small thing also, you get support. Towards the end of the training, we want you to become independent. See, at the 8th month of training, I don't want to tell open the file, type module, type this, type this. Will it sound good? No, right? Because that's the time where you should have become independent and you should have started thinking yourself. You should be motivated yourself. Okay. That is where you are ready for the job actually. Initially, you are still new to the subject, so we do very detailed. But as you go forward, the support is given in such a way that you do the things independently. I mean, not that we don't want to support. We want to create a setup where you start doing the things more from yourself. Will you be teaching SVUM, some other trainer? It could be mix of the people. I mean, sometimes I do. For example, there are two SV batches running now. I'm doing one of them. My other colleague is doing another batch. There is no concerns. As long as there are no concerns, things are fine, right? I mean, when there is a concern, we definitely take care of it. Because if alone I have to teach, I cannot do all the batches. Lab sessions for functional verification will be conducted between 9:30 to, yes, these are the schedule. Any other questions?
I'm from computer science background.
Yeah.
Like I finished my engineering in computer science specification.
Okay.
So I don't know about the electronics. Like I'm in very long
Okay.
So will you guys start from scratch? I mean,
Yes, the course will start from very basics. Let's say if I have to open digital design, for example. Let's say digital design starts with combination logic, let's say. It starts from the very basics of what is number system, how to do radix conversions, what is meant by k-maps, what is minterm, what is max term, what are the logic gates, how do you realize logic gates using multiplexers and universal gates, what is complements, arithmetic operations, boolean, everything covered from the very basics. First, you start from the questioning: why do we learn digital design? Why you should learn digital design? Then number systems, in depth of number systems. For example, we go through each topic like this. How to assign vector values. The point is, we don't expect you to come with any prior knowledge. It will cover everything from basics. The only three things I told you is you should have the right aptitude to at least understand the problem. Second is you should be motivated throughout the course. Many times what happens, let's say today's strength is 60 in the batch, for example. By end of the course, strength will be 50. So 60 to 70% of people drop for whatever reason. So though you may say it could be your fault, you are not teaching properly. We put same energy levels throughout the course. We keep calling them also why you are not attending or all that kind of thing. Still, that problem happens. So you may ask, what am I trying to tell you is good aptitude, the motivation throughout the course. Let's say course started in January till August, September, you should be completely motivated and completely dedicated to the course. Other than that, you don't need any prerequisite. We'll cover everything from scratch. Okay. Even if I go to Verilog, Verilog language also covers from very basics. Okay. Uh, how to work with GVim text editor. though not related to Verilog. Then basics of Verilog, how Verilog language has evolved, uh, what is the advantage of Verilog, then how to do some simple designs in Verilog, simple combination logic in Verilog. That level we start. This is where the things we spend more time. Actually. If typically, if I keep my code here itself, I can finish the same thing in 2 3 weeks. Just go through the slide, explain this is the code. Go through other slide. So we don't do that. Most of my presentations will be focused on the writing down. Here you don't find much code. Code is done in the classroom in live session. Okay. Any other questions? Take the next question. I'm in post silicon validation. Okay. My wish is to move to pre-silicon. I'm decided to take DFT. My choice is good or not. You can take DFT. The person who is working post silicon validation, he understands what is meant by test vectors, how the testing is done. You can move to DFT. It is possible. DFT will be a good choice for you. Okay, because at your experience level, DFT you can find job easily. Can we practice labs for any number of hours? Any limit there to the labs? Typically, yes. You will do maximum 10 hours right per day. If you occupy throughout the day, it will be problem. But otherwise, typically it's possible. 10 to 12 hours in a day is possible. And beyond that, you can't do also. Okay. It should be possible. Okay. As long as it doesn't impact the other students. I'm working professional, so weekend is more advisable or weekdays. Uh, weekend is more. Weekend is the only best option for you, unless you can take out time. Let's say in your office you can take out time from 9:30 to 1:30 every day and attend session. Then weekdays is best. Otherwise, you please go for weekends only training. Will there be any chance in VLSI for those coming from other branch other than ECE? See, ECE anywhere the term electronics is there. Electronics and electrical engineering. Okay. Any in your degree anywhere electronics is there or electrical is there, you're suitable. Companies will consider you. Computer science is also fine. Companies do consider. No is for what? Mechanical. Don't take up. Someone is mechanical engineering background. Don't take up any other stream. Don't take up because you'll end up wasting time and money also.
I know basics of programming, but I'm not really confident. But I'm confident in the digital part. So can I still, if I want to take content, can I take content or like, can
As I
I?
said, you want your inclination is for front end, right? You take it up to 2 months. You see the by the time Verilog course will start. You see your experience with Verilog learning. If you like it, continue. Otherwise, you switch to any other domain. Okay, losing 1 month is not a big thing. Right? Let's say you switch to some other domain, you go to the next batch. There's nothing for you to lose as such, but you can at least try that. Any other questions? I'll just end the session with the basic summary of the things. Uh, Once you enroll, you are given with one dedicated ID. Okay. based on that ID, one WhatsApp group will be created. In the trainer and admin will be added. Whatever support you need, technical, trainer will support you. Non-technical, admin will support you. Okay. Next thing is you can connect with the trainer for any kind of support sessions. It's in your hands how much support you want to take. Let's say you don't bother at all. You want to just have, come and go. Nobody will bother. If you want to take full support, also trainer will support you. In fact, we like more because at the end, institute success is about student success. If you do well, if you learn subject properly, you do well in the industry or in your job wherever you are. It is thus institute is has institute name will be there because of that. Okay, you have access to the videos for 2 weeks minimum, and you will have access to the tool 24/7. Anytime you can connect to the tool and practice. You can do any session, online, offline. Let's say sometimes you want to take 3 months off from the course, you want to rejoin, that is also possible. Okay, we won't put restriction that you have to complete compulsorily like that. No restriction. We try to be flexible with the student requirements. uh, there will be mock interviews, there will be presentation sessions, evaluation test. You have to attempt those tests proactively. It's not about getting 100% marks. It's about getting whatever score. Let's say you got 40%. Why did I miss 60%? What I should do to improvise on that 60%? That's the approach you should follow. Assignment sessions will be mentor guided. Every assignments you do, every assignment, there will be a trainer who will be guiding you. He may not sit with you on code, but when you are coding, wherever you are stuck, trainer will support you. Strength will be limited. Generally, around 25 students will be there in a batch, so that will ensure that you get that individual attention. When trainer can come to you, he can understand, he can give enough time for each student. And multiple industry standard projects will be there. That is where we majorly differ from the other institutes. Yeah. The projects are very important part of your overall course. Okay. Printed material will be given to you for all the subjects, and there will be dedicated soft skill training. Mostly people who come from metros like Bangalore, Hyderabad, Chennai, they don't need any soft skill training. They are already comfortable with their communication and overall English speaking skills. The people who come from non-metros, towns and villages, for them we have the soft skill training. Again, it's the student hands. You have to be proactive. I want to attend, please arrange. You need to understand that English communication skill is a very important part of getting a job. Okay, because you may be very good with the subject. If you cannot present your point, people won't hire you. So that proactiveness you have to take, and you can switch the course up to 2 months. Regarding the placements, we are very well connected with the industry. We have a dedicated team who keeps connecting with the companies, and companies also connect with us, so you get placement opportunities. We'll create one dedicated WhatsApp group, where, for example, DV, job support group. In this, our admin will keep posting the job requirements. So there all the students will be added who needs jobs. They will be given support through this group. Okay. Like this, as and when we get requirements, the trainer will keep posting the requirements, and through Google form we collect your data and we give to the companies. So this is where we keep posting all the updates. Okay. Something like that will be there for DFT, PD. Every domain has a dedicated job support group. Or let's say if I have to tell, over 200 members are there. Or this is over 2 years, I would say. We have this many people who need jobs. Okay, some people would have got job, we would have removed them from the groups. So this is the current situation. Any questions?
So I understand this having online classroom, weekend batch.
Yeah.
Isn't it? And one more thing I have, before coming here, I inquired online e-learning something is also there.
Yeah.
Self-paced learning.
Yes.
So that you don't need to attend weekend or
Yes. No, e-learning means e-learning by default come with weekend course.
so we can
Whether you attend weekend or not attend, it's your choice. Because e-learning is what? Access to the videos. Many times just you learning yourself through videos is is not very motivating. You need someone to guide you. Let's say you're doing some videos. Even if someone asks you how many videos you have done, one question is sufficient. You know that someone is tracking my progress. You know that someone is okay to answer. Someone is there to answer my questions. That's the basic reason why we do weekend sessions. Second is to do the labs, because by just doing yourself videos, you don't know how much expertise you have gained. So sometimes we cannot teach all the practical things through in videos. Practical things can be taught in interactive sessions, further weekend sessions. So it is possible e-learning, but whether to attend or not is your choice for weekends.
Is there any reviews on weekends? So interaction sections with the trainer.
Yes, that is what I said, right? The weekend sessions are interactive sessions with the trainer.
I mean, what I want to say to analyze how much we learn.
Yes, it will be there. The trainer will go through your submissions. The trainer will check how you have done all those things. Trainer will check.
Simply want the progress report of that.
Yeah, it will be there. It will be there. Every student will be tracked. I mean, uh, we keep track of each and every student. I mean, like for a batch, we maintain a file where summary will be written. Like, for example, I did your training. I'll write a report like this person is good. This person go to the next batch. That level we have to do. Only then we can divide the students into multiple buckets and provide the required support. Because without proper planning, if you do, you won't get jobs. Students cannot get jobs. So we need some systematic approach on how to analyze the student performance, how to provide them support. Any other questions? So if you don't have any questions, we'll end the session here. In case you want to enroll for the course, uh, our admin might have sent you the details. Uh, Enroll before enrolling. There will be a link where you can make the fee payment. Which you can make the payment and confirm your enrollment.
भी नहीं है तो क्या जाएंगे
So
बाहर.
right now to confirm your enrollment, you can pay 5,000, and once you
हाँ?
paid, you can fill this enroll form.
मीटिंग चल रहा है.
Admin will get the notification about your enrollment, and they will provide you the further support. All the support will be provided through that WhatsApp. You don't need to phone, you don't need to call our phone, you don't need to send an email. That one group created for you with some number is the point where you post all your queries. Any other questions? Thank you everyone. We'll end the session here.